Yep.
So let me pull it.
Okay, welcome everybody. Anne's going to go through the agenda for today. We have a pretty packed agenda, and so she'll go over the agenda, and then I think you're gonna go over the agenda, and I think you're gonna take a section and introduce some technology that we're using.
Okay.
Great.
Well, hi everyone. Today's agenda, we're going to start with any new attendees who haven't gone to previous meetings and just give a quick introduction of your name, what you're interested about in the study and stuff like that. Then we'll go through collaborations with international companies, universities, and the student learning system. Then we'll talk about the show Advancing with Ted Danson. Next, we'll cover the importance of filling out the paperwork and also reviewing previous meetings. Next, we'll go through communications. Specifically, there's a Slack channel that's been created. Lastly, Dr. Brad Hyatt, Dr. Vishesh Singh, and Paul Martin will go through the working theory. And Paul, do you want to talk about the collaborations, or should we do introductions first?
Why don't you do introductions first, and
Okay.
that'd be great.
Okay. If anyone would like to speak up, who hasn't been to previous meetings, now would be a great time to do that.
I think I've missed like the probably all of this like formal meeting earlier due to different reasons, and but yeah, I think it'll be nice for me to introduce. I'm Vishesh Singh. I just completed my PhD. I was working on data-driven production planning and control for construction projects, specifically on-site building construction, where I was working at the intersection of construction management or the production planning, and then the operations research. So looking at construction as a production system, and then philosophies and principles from lean manufacturing. So mixing all that with methods, data-driven methods, and some tools from data science. So applying data-driven production tracking from on-site, and to feedback into the production control loop, and then using that historical data to predict future production plans. That's kind of my background. And yeah, I was not able to join earlier as I was trying to finish my PhD and get things sorted. So looking forward to joining every week now.
Yeah, welcome. Yeah, he was trying feverishly to get his PhD complete. So congratulations. Woohoo!
Yep.
Behind you now. You're world expert in your knowledge now. So it's great.
Yep.
So I'm sure all the PhD
to apply the knowledge.
Oh man, I know what you went through. So congratulations. All right, what's next on the agenda? I sent that PowerPoint to you, by the way, as well.
I believe Juan Miguel is also a new member. If you would like to introduce yourself.
I almost felt like a boomer for a moment there. I forgot how to unmute. Thank you for everybody for letting me join. My name is Juan Miguel Garut. Currently employed with Wharton Smith. We're a large commercial construction management firm. I've been in the industry for just shy of 20 years now. Half that time was in the field on the operations side. The other half of the time spent in pre-construction, which my current role is in. So always had an interest in space, science, and when we saw you, Paul, there at the Advancing Pre-Con, your presentation, the workshop on this piqued our interest. So I'm glad I was able to join when I did.
Good.
Looking forward to it.
Yeah, that's awesome, and thank you so much. And Dr. Brad Hyatt, Dr. Vishesh Singh, and myself will be presenting at the American Society of Professional Estimators, a national conference here next week. With that said, I think we'll have an influx of estimating philosophy theorists that will be joining us as well starting next week, so which is great. All right, next on the agenda, Anne.
Yes, next is, do you want to talk about the collaboration with international companies, universities, and the
Okay, so
program?
we have the approval from Johns Hopkins and NASA to expand this study internationally, and there's a lot of interest in this. So a couple things. That means that we'll be expanding to large international companies. One of them that we'll be reaching out to is a colleague that's very interested in this is Boyd Construction, which they're all over the world. They're based out of France. And then universities. Right now, we have the Ministry of Construction from Vietnam that's joined the team. Because of time frame, that's going to be a little tough to get them on these meetings. It's the middle of the night over there. So we'll have to figure something out. They'll be watching the recordings. But along with that, we've teamed up with two of their major universities of engineering, and there's potential for, they've already reached out to us. There's a professor doing a sabbatical here at UC Davis, and he's an expert in space construction materials, actually. And then also, anyway, just so you know, we're kind of moving internationally. So I wanted to bring something up, and this is an amazing opportunity for students. Now, Anne is an intern for the Institute over the summer, but in the spring quarter and in the fall quarter, her and two other colleagues will be continuing their work as an engineering student, and they get credit towards graduation in the engineering degree. We call it variable unit, and they'll be continuing their learning process of what we're doing. And along with that, we will be doing the same thing for the two universities in Vietnam and South Korea and Louisville. I haven't reached out to them yet, but we will. Brad will be reaching out to you, and maybe you and I have already talked about it, and then we'll deal with Iris we'll reach out to Professor Iris Tomlin at University of Berkeley. But what we'll be doing is having 3 students from each university that will have a learning opportunity. And so the students will be working independently, which will coordinate on what the students are doing, and the professor. Each university picks the 3. They need to be exceptional, and they need to speak English and fluently. And so there'll be 2 on the major theory of estimating, and then 1 of the 3 from each university student. They'll be undergrad, typically. Will be dedicated to return on business or return on investment, which would be more on the business side, forecasting and tracking. That means then that they'll come out of the business departments within the universities, unless there's a case that they're exceptional in that. But at any rate, and then we're also reaching out to science departments for various reasons, which I won't get into today, but it's pretty exciting. Okay, so that's all I wanted to say about that. Stay tuned for that. What's next?
Next would be advancing with Ted Danson.
Oh, okay. So we've signed the production agreement with the show. Taping starts, the preliminary organizational side starts in October, slated to air the quarter of winter. I've reached out to just a few of you. There's funding, logistics that we have to come with up on our side. There's 2 universities. Brad, Fresno State has already committed, I believe, $5,000. And he's going to go into the financial side real quick. And then we'll be reaching out to the private companies. UC Davis, more than likely, we've started the ball rolling to probably come up with 5 to 10. What else? There's a lot of great opportunity. Stay tuned on this one because there's a lot of excitement. The production crew is really excited about this. And they'll be taping at Johns Hopkins Applied Physics Lab and UC Davis Visual Lab. So with that said, I'm going to maybe hand it over to Brad for a little more clarity on some stuff, including some information sessions we'll have on funding.
Yes,
Brad,
thank you,
tenure
Paul.
it.
Thank you, Paul. So, as you all know, Paul is always doing a great job of showcasing what this group is working on, and really is continuing to work at different conferences and do different presentations with some of us and some of you. And from that, this exciting opportunity that he discussed with Advancements, a series hosted by Ted Danson, which I've put the link to the TV series here in the chat. And but it's a great opportunity to showcase what this group is working with, what the Institute is showcasing, and all the work that we've done to date. One of the aspects is that the production company that puts this together, they require a little bit of skin in the game for organizations that are going to participate in this TV show. It's around $48,000. So again, as part of my representing Fresno State, we have committed to putting some money in for that. I know that Paul has worked with UC Davis on the same as well. However, we are wanting to be able to fully fund that through the Institute. So Fresno State will be giving the money to the Institute, Paul's Institute, to do that. And we're looking for others to partner on that as well to be able to move forward and showcase the work that we've done. I think that it's important to just recognize that, one, the Institute is a nonprofit organization, so this would be done as an official donation. So for whatever that may be worth with your companies or organizations. And the other thing is that this represents the work that all of us are doing together collectively. The Institute's website does a really good job of kind of talking through some of the high-level discussions that we've had to date. And it's really a launching point for us to be able to move into bigger and better things with Johns Hopkins and NASA, to really get into creating the theories and then also the applications that are going to be necessary to realize this work. So so that TV show is really the opportunity to showcase all of that and then to launch us to the next phase of this work.
Sure, and thank you, Brad, for that. So we'll be having 3 or 4 information sessions instead of contacting each company, and we'll go ahead and let you know. Also, the Institute doesn't take any. It's dollar. A dollar in goes right to this 100%. So just so you all know. All right, so that's the business part of it. So we're done with that. And what's next, Anne? Good job putting the agenda together. Thank you, by the way.
Yes. Let's talk about the importance of filling out the paperwork and reviewing
Yes.
the meetings.
Yeah, and so of the 10 or so that are on here, we filled out the paperwork. I don't know. Wait a minute, did I even fill out the paperwork yet? I don't know. I forget. If I didn't, Anne, I'm going to do it now. But let me, so what it is on the website. You probably already know about it, but there's some very short surveys. It's so important that we get that. Right now there's like 45 on the team. We know that we have around 10 or 12 per week that show up to the meetings. But we can track who's looking, not who is, but how many are looking at the meeting minutes, and it's actually quite high. I'm very impressed, actually. And you know, we encourage everyone to look at the meetings, and as part of that, we want to make this very easy for you. So the forms are very easy, very quick, but it helps us organize this think tank that we have. Otherwise, we're just guessing. So please take time and do that. We are committed. Everyone on this team are either managers, high level, you know, folks within organizations, whether it's university or private. We know everyone's busy. That's why we don't expect 100% to show up to these meetings. But we're also committed to make this whole process as easy as possible. So what we're doing, Anne is, she's just been key in this. That data room, I think, is just fantastic. It's easy to find. It's very visual. The other thing is, oh boy, I lost my train of thought. I just forgot what I was. That's what happens. I'm turning 60 here next month, so I guess I have to get used to that. Let me see here. It was about filling out the. Oh yeah. Sorry for the brain void there. So as part of us keeping it easy, Anne has gone through, now check this out. She's gone through all the meetings and she's tagged the important things. So you don't have to just like, what is this meeting about? And, you know, if it's an hour, all of the pertinent important things have a timestamp labeled where you can just go to that, you know, oh, this looks interesting, and then just go to that. And then it's up to you when you want to disengage. But that way, you know exactly where to go to, review it very quick, and off you go to the races. So thank you for doing that, Anne. That's amazing. And we'll do that for every, we'll do that for, thanks for the comment on that. We'll do that every meeting, and it's just going to save us so much time. So awesome job. Okay, let's move on to the next agenda item.
Okay, next part, we're going to talk about communication and Slack. So I've gone through and I think everyone on the email list has received an invite to join the Slack. Essentially, let me see how to, I don't think this screen is being shared. Let me.
No, we don't see a screen.
Okay, let me redo that. Go share. Okay, so essentially when you join the Slack, there's a welcome page that walks you through.
Can anyone else see the shared? On my screen, I can't, but my settings are off on Zoom today. So can anyone else see the?
Yeah, I can see it.
Okay.
Okay, perfect. Thank you.
All right.
Well, we'll figure something out with your.
Yeah, I guess so, man. Probably user error.
When you come in on the welcome page, it has access to all of the links, the forms, so that way everything is together. You can walk through, and I want to make it very clear that this Zoom meeting link is going to be reoccurring. So if you ever lose the access, you can find it right here or on the data room. We have one room that's for open discussion, so anyone can share anything. And when you go in, the 11 lenses of descriptions, over here, if you click on the PDF, it'll give you a walkthrough of exactly what each lens is covering. And depending on what your lens of expertise is, which please fill out the form, it'll only take a minute, you can go through and enter that specific channel to talk about it. Other than that, it should be fairly simple. If anyone has any issues joining the Slack or figuring out any logistics, just reach out to me and let me know.
And the reason we have Slack, and I've used Slack on, $2 billion, $4 billion projects. And it's pretty cool, but it can get very, very complex very fast. Well, Anne has put a very visual thing together that will make it easy for everyone. We have to be careful not to make so many threads that it gets complex. So we'll keep it easy. I think she set the framework to keep it simple. Now, here's why we have Slack, is because right now we have Zoom meetings and email. And as we're moving now into the next phase, which is completing white paper and then taking it to another level, which is deep dive into the subject matter and then implementation. which is a huge deal. The communication within our group just needs to be more sophisticated. So Slack will be something that we'll have a training session, probably taped training session that Ann and I will do. And we'll have it up there, but it's just a way, we want to make it simple for it. It's a way that you can have internal conversations. Pretty soon, we're going to be breaking up into think tanks of our areas of expertise, and we can have conversations accordingly. So I've used it. It's very simple, but it can get away from you if you're not careful. So we'll make sure that it is not going to get away from us. And everything we do, we want it to be efficient and save you time. So good job, Ann. And what's next there?
Okay, let me stop sharing and go back to our agenda. Okay, lastly, now we're gonna have Dr. Brad Hyatt, Dr. Vishesh Singh, and Paul will go through the theory. And
Okay.
let's pull up the,
Start on the first page. Let me kind of explain it a little bit.
okay, do you know which email you sent that,
It's the last one I sent. Did you get it?
is it to my student email?
It's to your, let me see where I sent it. Just a minute here. Sent. There, I sent it to your, I'm clicking on your name right now. I4CI.
I didn't seem to receive it, but I can check again.
It looks like it's sent on my side.
Oh, yes, okay, I just sent through.
Okay,
Let me
perfect.
share that right now.
Brad, we're going to have each of us talk. I'll talk through the general theory and then talk about the business case on tracking, just like we spoke this morning on the ASPE presentation. And I've talked to Vishesh, he'll take care of tracking theory. So the reason we're, well, I have a problem because I cannot see a shared screen. You know, all I see is speakers and I literally can't see it. And I've tried all the settings. Let me do this. I'm gonna,
Maybe rejoin, disconnect, come back.
well, if I disconnect, I think it's gonna throw people out. I don't want to do that.
Use the meeting, right? Maybe.
Let me do this. I think multiple screens is kind of screwing it up. So what I'm gonna do is get off the screen. Let's see if that helped. It didn't. All right, let's do this. What I'm gonna do is I'm gonna pull up the PowerPoint. Here, I'm gonna pull up the PowerPoint and then I'll just talk about it. Nothing's ever easy, is it? Okay, and go to the first slide.
Yep, it's on the first slide.
Okay, good. So the first slide, that's essentially that first slide is the theory. That's in my office, and again, we talked about the complexity. So what we're gonna break doesn't look easy, right? But when you go through it, it actually is quite easy. And so we're going to break it up into very specific components. So you have a kind of an idea of what the white paper is in the process of doing. I'm a little bit behind on the white paper, of course, but we just need to do this the right way. And the white paper is not moving into the expert areas. It's just explaining the flow and the major structure of the process. So if you look at all the different nooks and crannies of this, think of it as the whole thing as a whole, and look at it as if, you know, the top portion where you see the time, where the top portion is moving this way and everything goes back the same way or the opposite way. But this may sound counterintuitive, but what we need to think is whether you're going this way in time or this way. The unifying aspect of it is that they're in sequence. So if you're moving forward, you're moving backwards at the same rate. So, you know, that's why we have a two-way flow. We're getting pretty far out on this as far as far out. We're getting pretty sophisticated in our working and all of the nooks and crannies that we have to do. So we're going to talk about two very important aspects. Let's go to the next slide now. And it's a little hard to explain on this one. So Anne has put it, converted the board into a PowerPoint, which we're kind of working some things. So I want to just talk about some very quick, what we call them are foundational staples within the structure. So, and I have another slide that will break this up into color codes. We're only going to concentrate, although there's 12 different off-ramps of expertise and how it all ties in together, because no one's an expert on all of the stuff we have to do, not one person. So that's why we have so many people on the team. So we're going to talk about very specific areas. And before we go to the color code, because it will kind of obstruct what we're doing, because that is on the first one where it says on the left side of the page under pre-launch, this area here with all the circles and yeah, thank you, Anne. That is integrated project delivery, much like we'd see on complex projects here on Earth, but it's on steroids. It's concentrate, like concentrate orange juice. And there are people on the teams that are expert in integrated project delivery. But this is how we communicate and coordinate and align research and development. So one thing to note is we're putting this estimate format together. We have to come up with very detailed breakouts, work structures before the technology is settled on. So that's not an easy task, but it's something that we have to do. And I'll give you an example of that is habitat. Well, there's all these companies and studies that are going on well, what are they made out of? Is it inflatable? Is it structured with built and do you use the moon riglet, the dust material to bank it up the structure, or do you have a freestanding structure? Things of that nature. What roads? Is it going to be a powerful laser that fuses the melts it, essentially turns it into heated silica or kind of a glassy substance? Or do they use the riglet to make like a moon concrete? You know, all of this stuff. What's the electrical infrastructure? Things of that nature. All of these technologies are being built or studied. So, so this process, there'll be some that are already known and some that aren't. So that beginning stage is one of the most important things. So we move over to where the full system predictive engineering and what have you, is that we moved from the integrated projects delivery, and you see those 3 blue arrows where it says master plan. Master plan is architects and engineers are brilliant at this. So we have some on our team that are, how fast do you do a master plan, and how do you adhere to the master plan integrity when everything is moving so fast? And a lot of the technology isn't because it would be nice to have. A lot of the technologies that are being developed and implemented will be because you have to do it or you die. And a little different situation than we have here on Earth, right? And although tracking cost is important, we talked about this earlier with a couple of colleagues, tracking target value design or keeping it within a certain budget, of course that's important, but there's so much other things at stake. We may want to consider that it's more important to understand exact state, no matter where we are, and then you can manage as a second output, you can manage costs. But the most important thing is just where are we with a high level of certainty. And we're using it as absolute minimum variance to our predicted state. If you think about that term, it's a pretty powerful term, and it's very difficult. Well, in this section where you see where all the arrows are going out, that's the master estimate. It has to talk to the integrated project delivery teams, the research development teams, the financial teams, things of that nature. Work breakdown structure, it's the communication. Well, at that same time in this area, they're also developing models of verification, models that that predict and do simulations and what have you. Everything talks back to the master estimate. Last week we talked about the work breakdown structure that NASA uses. They only use 7, and it's mostly just financial. We predict that we'll probably have 20 different lines of coding that we'll have to implement some sort of AI, and Brad will get into that, and Vishish a little more in detail. It's pretty exciting stuff. Then, we're moving down the timeline where we have the breakouts and components and things of that nature. And Vishish will kind of talk about that. Being always aware of the actual reality of what's happening, the capture, which NASA would be involved with their G2 system and other things. And it's all about making the historical faster and more accurate. So the first mission, things may be more of a guess, but as probabilities are checked and verified, and you can see, where risk has been heightened or lessened based on what was the predicted state, then you can the team would be able then to go back and check the spikes of risk. How did it end? Even if there was a thought of a predicted risk or a variance of a predicted state, you would see a spike, and then you could concentrate on that. I want to remind everyone that they're just not going to show up and do a full-blown city on the moon. It's a process. You have to test in small scale, and then you ramp up from there. So there'll be ramp up from there. So there'll be a lot of opportunities to refine and start building a very sophisticated and learning environment, automatic learning, through a two-way backflow loop. And then when you get to the bottom, you see that backflow starts moving back the other way, and where it says a rigid state and an agile state, which is the blue dots there at the bottom of the timeline, and then the rigid state. Let me explain what a rigid state is. Rigid is it's set at the very beginning, which are the things that don't need to be moved or you know, they can stay constant no matter what. And then you have an agile state, which, well, it depends, right? You could, yeah, it's rigid, but this is a little different, you know? And so instead of locking everything into a rigid state, with the system has, or the theory has an option to be a little more agile on the current, or on whatever the unique aspect of that is. And of course, those have to be tracked. We talked about the work breakdown structure, the number coding, and again, just a reminder, go through the first 20 pages of the NASA work breakdown handbook, work breakdown structure handbook. Those first 22 pages, very fast read, is going to tell you exactly what you need to know. Just think about those 7 layers of coding. We're just going to keep going. They set up an infinity amount. We're just going to keep going to the right. But it's important. These are just going to show up as words, and many of us won't, you know, on the team and NASA or whoever's on the mission, they won't understand what those are. So think about the same type of ordered hierarchy as we do on the numbers on the description. It won't just say screw, you know, for attaching 2 systems. It will have a hierarchy of how you describe what it is. So you can look at it, you know, it's code, but the code's mostly for computer and artificial intelligence to tell us where we are. Verifiable, everything's verifiable. But we have to come up with the same system on the description side, that otherwise we don't know where the state is without some sort of verification. So we need some folks on this team, estimating folks to dive into that, and I'll talk about that down the road. Go to the next slide. So this is kind of what it looks like. Okay, don't freak out on this. But I wanted, now remember there's 12 of these, but I wanted to take the first 1, 2, 3, 4, 5, 6, 7 areas of expertise and lay it over so you can see that these things have an order of expertise, but they all kind of tie in together. So let me just explain what these are. And then I'm gonna, after this, I'm gonna take 2 more minutes to explain this, and then hand it over to Brad and Vishesh. So the first one is integrated project delivery. Now, that happens at the beginning, and you can see the influence if you could just trace that box there. And the influence, the yellow, yeah, right there, yeah. So that's primarily at the beginning. Now, once the things are seen, are, you know, decided on, things of that nature, you're still going to have interconnection, but it won't be as intense as at the beginning because we're setting the journey. Then the next is estimating theory and structure. So this is where we're putting the master estimate together that that ties into everything. It's pretty much at the beginning, but when we put the theory together, we don't want to be inventing theory downstream. It has to be fairly early in the process. And we call it master estimate structure. And you ready for this? This was, we didn't plan this. Vishesh and I were talking about it before the meeting. Check this out. What's the acronym of master estimate structure? It would be MESS. We couldn't plan that out. It just happened. But at any rate, master estimate is what dictates the model structure, simulation models, engineering models, cost models, unit break formats, whatever. It's literally the master of where everything gets tied to, and everything talks to the master estimate. Okay, and then we have reality over to the right. Remember, we're kind of going this way. We have reality capture and predictive models and simulation and simulations. And again, that is just a form of, we come up with a master estimate. How are we going to verify it? And then we have so that's reality capture, and then predictive modeling, which also includes simulation. And simulation is important because the astronauts and the autonomous vehicles and mechanisms have to rehearse. They have to go through all sorts of scenarios. Then we have verification and transitional state. Transitional state means we're at a verifiable state with, and then it has to transition into a reality state. 11 is backfeed. So now we go the loop and we're going this way. There's a theory behind that. And then data conduit and reporting structure. That is essentially what Brad's going to be talking about. And then Vishish will be talking about 9 and 10. And I'm going to hand it over to both you. And why don't you go back to the one before this one? All right. And then I have someone, a very brilliant person. He's going to be putting motion to all of this stuff in a interactive live PowerPoint. It will really show these mechanisms moving and how they move. He's working on it right now. So, all right, Brad and Vishish, whoever wants to go next.
Maybe I can go next, and then Vishish, I'll hand it off to you after that. But just quickly, in a few minutes, my background is construction management, civil engineering, specifically in data analytics. And so looking at this model that Paul has put together and discussing with him and some others, one of the key things that we see that's important that Paul has alluded to moving forward is that we can't use systems that we typically use in estimating. So using a spreadsheet is just not going to work for something as complex as this. Even a lot of the estimating software that's out there is really not going to be able to handle the type of model that we are envisioning for this. So, but we do know that we have AI and advanced analytics that have the capability to do many of the things that we envision. And that's going to be important tools as we move forward and start to dig into this a little bit more and develop these processes and then overlay those processes into these different software platforms that will be developed. Just a couple of things that more specifically that we've talked about is, first off, this is going to have to be an extension of what's been done before, but in a much more complex methodology like I've talked about. So it's going to be important for us to think about what are the requirements going to be for lunar construction, and then start to break that down into very finite pieces and parts, and then tie those all together into the master plan and high-level WBS structures in a way that NASA can utilize that and the construction teams can utilize that, but also with enough detail that we can start to develop a cost estimate, but also look at risk, return on investment, and those type of things as well. So really, it's not just a piece of estimating software that's going to be developed, but it's going to be this comprehensive tool that can be used for many, many aspects. A couple of things specifically, or one example I should say that we've discussed is if you have, I'm just going to use a screw, that they may not use screws as we think of them in the moon for lunar construction, but if we think about that from our context here terrestrially, if you think about a screw on a construction project, that screw, that specific type of screw, may be used in various different portions of construction, various different assemblies, and those assemblies roll up into the overall project. But if we track that screw, when we know the part number of that, that's kind of a finite element in itself, and then that ties together with the labor that's required to install it, the tools are required to install it. We envision that robotics will be a huge part of this, so perhaps the robotic apparatus that will be used to install this screw. And so you have all of these different aspects that are tied to that. And so then you have to think about, how do you develop a database that can handle all of that information? And that's where data analytics, all of these frameworks really start to allow a comprehensive view of all of those aspects and tie everything together in a way that we can track what's going on from the time that we plan it, the time that we actually go through and start to analyze how it's going to happen, develop models for how it may happen, run various scenarios for models, and then ultimately build it, which as we get to the end of that that line, it kind of feeds back through with the actual reality of what's happening for the cost and the time and those type things. And we can get more realistic estimates once we start the construction on the moon itself. So that's really the concept of how this all ties in, this master plan, all the key elements kind of in that middle section, or the kind of the starting to the middle section. And then that all will roll into and provide the capability to the verification that Vashish is going to talk about a little bit.
Yeah, nice. Thank you.
Yeah.
Ted, you're
Yeah, I think that's like the basic foundation you need in terms of setting up a system like this, where data is key, but like how you structure the data, how things are connected to each other, becomes very important at the early stage, so that you can use that power of data and like the relationships within your data structure, to actually do the things that we want to do, in terms of like estimating for construction that no one has ever done, but also learn as we do it, both on Earth while we are simulating these processes, and then as we build it out on the lunar surface. So I think that background of a data mindset, and then your estimate and your work breakdown structure and your everything else around it is built around that data model is essential. And then that basically gives us this like superpower of using reality capture, and that can be from various ways depending on, just as we don't know the means of like the construction right now, there might be different ways of verifying the actual work as it's being done. Like some common ways we have started to use on Earth include visual verification that can be computer vision based, either through visible or infrared cameras, or through radio frequency based IoT sensors that can sense objects, or that can track humans or robots or different kinds of resources. And then there are sensors we put into the material itself to see if it has hardened, or the temperature and all that can signal in terms of both your production like times, but also in terms of your quality and other defects that might come up. So all these sensors they produce a lot of data, but connecting it back to how it connects to time and cost, and then also production at component level, at work, like at various levels of your work breakdown structure, and then tying it back to your each resources in terms of human, robots, machinery, or tying it back to your material in terms of components or raw material you're either hauling from Earth or excavating or producing on Moon. So this the being able to do that in a live loop as you're building on Moon needs a system that can collect all this data and connect it. And that is kind of very related to my PhD, which I just did. Is we basically created this new concept of like a construct called work density, where you're trying to collect all this contextual data around production. So, I mean, at most, when we are doing estimation or planning, we know like there are certain inputs, but we only track the final amount in terms of the dollar or the time, which is good at a very high level and the kind of computation humans are used to in terms of benchmarking or in terms of um, looking at historical data. But if we want to actually like use or leverage this system, we need a system that can contextualize these cost and time with respect to who's doing the work, where is it being done, how is it being done, so all the means and methods, and then what was put in before and what is going to be put in after in that sequence of steps in a process. So this system at the end where you're learning from from your work as it's being done, this basically needs a comprehensive sources of data that are being contextualized and connected back to the production, that can then either like flag off risks that are different from your estimates or your plans. Also, like trying to identify any kinds of variances that were like built versus the plan. But then also you, as you're doing your next iteration of estimates or next iteration of projects, you want to identify things that be risky the next time, given what data you've collected in the past. So this loop is not only on a real-time basis when you're controlling the system, but also as you're building new estimates and new master plans, because you're learning from the mistakes and the variances that you produced from the last execution. I think, I mean, that's the higher picture, but this can be done at various levels. And as Paul was mentioning earlier, like master plan will be divided into like smaller sections or lenses, and then each one needs to do it internally in their system as well. But as a whole, this feedback of both two-way flow between planning and execution needs to be built at the very fundamental level of how the data is collected.
Yeah, very, very good. Outstanding, both of you. One thing that you mentioned, and I think we should maybe think about is learning from mistakes. I think there's the other side, which is learning from the success of prediction. You know, there's that type of alignment or honing that, hey, we did it right. And then understanding, did you just do it by the skin of your teeth because, you know, you just avoided risk as chance or whatever, but both of you, very good job. So follow up, we got 1 minute. First of all, control. Oh, we're not losing, when you hear a lot about AI, stuff like that, we're just dealing with so much information to organize all this. We're literally thinking that, you know, we'll have to use that, but remember the human experience is not taken out. And so humans are involved always, the experience. The other thing is we need to go into philosophical discussions now, and we'll talk about how we're going to do that. It's not just me talking or individuals talking, which now we're starting to expand out, as you can see, to different expertise. And so we'll be sending out an email of how we're going to do this, where it's, you know, where we need to get everybody's opinion now, and collectively, and come up with some deep discussion and poking on, you know, on as the theory is going to, you know, just implementation and means and methods of process and in theory from all of our lenses. So we'll have to come up with this. We don't, these meetings are more about up to speed things, but we need more meat and potatoes on as far as unifying theory and discussion. Next is we need PhDs that are on the team to let us know your title and upload your thesis, or excuse me, it's a master. Upload your dissertation, and we'll review it and see if there's sections that would align with the theories and process, and maybe you'll already know. Like Amir, I see a connection right away on means and methods, and so it'd be great to get your thesis online. Maybe you've already done it. That's all I have for today. Is there any comments before we move on and we go about our ways?
Paul, Anne helped me to upload the dissertation already. Thanks.
Oh, that's awesome. Yeah, thank you. That's great to know. So, all right. Well, with that, look out for the informational session for the Ted Danson fund logistics. So you'll be receiving that, and I think that's it. And then also how we're going to organize our discussion. So in the interest of staying on time, I move that we see you in a couple weeks.
All right,
Sounds
everyone. Good to see you.
great.
Bye.
You.
Everyone have a great day. All right, thank
Thanks,
you.
everyone.
Thanks.
Great to see you. Hey, Anne, can you stay online? Did I lose you? I already lost her. All right, John, and I'll see you guys later.